There now. Welcome back to the workshop. So today's episode, as in the title, is us on these Cooper S cylinder heads. So we actually have one done already. Well, when I say we have it done, it's almost finished and ready to be done. I'll give you a little update on it. It's over there. This is the second of the two cylinder heads. So just for anybody who hasn't been following this particular series, these are the Cooper S cylinder heads that were sent to us by Cole, Classic Mini DIY. Link in the description down below. Cole sent the cylinder heads over to us for us to refurbish the cylinder heads. He also sent us over the rockers, which you've seen on the last video we shot. We've double set of Cooper S rockers to rebuild for him as well. Today we're on the cylinder heads. We're still waiting on a reamer to arrive into stock to finish off the video on the rocker shafts. I actually thought it would be in stock this week, but things are a bit slow at the moment with general worldwide shipping, as everyone knows. So hopefully that'll be in stock next week and we can get that video shot. So where we are with these cylinder heads at this moment in time is this cylinder head went off and got chemically cleaned. That's so you can see we're back to the cast iron. Then we put it in a dip, which I use here in the shop. The name escapes me completely now, but it's a rust eating chemical basically, so it takes all the rust out of the inside of the cylinder head, which has worked really very well. We've put it in the milling machine and we did a very light surface across the top here. We measured the cylinder head this end and we measured the cylinder this end, and there was a discrepancy, so we checked parallel on the bores for the valve guides to get a square parallel reference surface, and what we found was that the cylinder head, when it had been skimmed before, was 5/1000 out of parallel. So basically both surfaces of the cylinder head should be completely in parallel, and when we set the cylinder head up with a parallel bore on the valve guide here, what we found was that the cylinder head was 5/1000 fatter here than it was there. So what we did was we shimmed the bottom of the cylinder head, skimmed it, and now we're completely in parallel here, and we're also in parallel on the valve guide bores, or the valve guide bores. Next thing I've been doing is I've been machining these valve spring seats. I have a video I did on this, probably one of the very first videos I think I ever did on the channel. I'll stick it up, and it's in this corner, isn't it? Billy's furtively pointing there. It's up in this corner. I'll stick a link in there to that one. I'm not going to spend loads of time showing you how I did this, but safest to say, it's a really worthwhile thing to do. On the other S cylinder head, there was very little discrepancy in these, which is where you can run into trouble. Because you think with a small amount of discrepancy they might all be like that, and this cylinder head was absolutely not that case. Some of these valve guide or valve spring seats were 1.25 millimeters in difference in height between one and the other. I'm now honing right in on the last little bit. You've seen me measuring there. I have every single one of these now on the dial indicator gauge within 1/100th of a millimeter. Bar this one here. So what we're going to do is we're going to line up on this one and take what's left. So when I measured this one just moments before you came on the camera here, what we found is the discrepancy here is 0.03. Now I'm just going to give you an idea how I do this. There's loads of millions of different ways of doing it. You could bring it up here on the knee, or the 0.3 of a millimeter, but my milling machine is from 1968, so it's imperial, and I do all my measurements in the metric system. So trying to convert between millimeters and the metric system is not that quick. So working out thousandths and that on the knee to bring it up, it's a bit slow. Also, using the knee in order to cut these is not a great situation, because I actually need to be able to bring the quill up, move between one valve guide boss and the other, move it out to measure and that. So what I actually do is I just set the knee solid at a certain height. I set the head, and then I can move out on the X feed, take my measurement, and then move in. And what I then do is I have a dial indicator gauge set up here on the quill, which I'll show you now. So this is moving with the quill. This lump of metal here is moving with the quill. I have a dial indicator gauge set up in such that as I move the quill down, you can see what it's doing on the dial indicator gauge is it's giving me a measurement of the spring seat. So what I know now is that my spring seat here is 0.3 of a millimeter too high to match with all the others. Every other one is within 0.05 actually. I try and get them between 0.1 of a millimeter is what I try and get them to. I'm actually down to 0.05 is all the discrepancy across the board is here. So what I need to do is I need to take 0.3 off of this seat. So what we'll do is we'll turn the milling machine on. I'm running this incredibly slowly. The cutter is running there now at about 150 RPM. When you're cutting cast iron with what is a shear cutter like this, slower speeds are always better. They get you better finish. What I'll do now is I'll bring my quill down until I start hearing the cutting action happen. So it's coming down now onto the seat. And I'm looking there now. Okay, now we're rubbing the seat. So what I'm going to do is bring my dial indicator gauge into 0. And we're going to bring in 0.3 of a millimeter of cut. That's 0.1. 0.2. And we're creeping up on the 3 now. So bring our quill out. Stop our mill. Cycle out the milling table. Now, if you have earbuds in, just mind your ears for a second. We're going to give this a little blast of air. Fair warning. Get our little measuring instrument. Always, when you put a measuring instrument down, always check your 0. The 0 reference I always start with is over here at the thermostat housing. Valve number 1, valve spring seat number 1, and that is always my 0 reference. So I check my dial gauge. And you can see my dial indicator gauge there is giving me dead on 0. But he's going to get you a bit of focus here. Dead on 0. The one we just machined was this one here. And we're going to check it there. And what that's showing us, let me just get this to sit in there just nicely. Okay, there we go. So we're between 0.05, depending on how I move this, and 0.1, which is exactly where we want to be. So what we now have is all of those spring seats in there at near as the height we want them to be. That is our spring seats in near as what we want them to be. The next operation in this is going to be to do the combustion chambers. We have to set the height of the combustion chambers. But before we do that, I need the valve guides in. So the valve guides we have are cast iron in this head. We use bronze ones in the other head because the engine Cole is building is going to use that other cylinder head, that first cylinder head we did. And this is a second cylinder head that the customer asked me to do for 2 reasons. One, we weren't sure if there was any cracks in either of the cylinder heads. So Cole said, I'll send you over 2 of them, pick the best of the 2 to use for the engine. And if the other one is salvageable, do that one as well, and the customer will keep it in stock as a spare. Both cylinder heads were perfectly salvageable and perfectly machinable, so we're going to end up with 2 complete cylinder heads out of this. This second cylinder head, we're going to just basically put this back to absolute bog stock standard original. On the other cylinder head, we're doing a few HRE tweaks to make it just so. All right, so we're going to put iron guides. We've got 2 different type of iron guides that we're going to use. We have the exhaust iron guide and we have the inlet iron guide. Now, over the years, I have found through my own experience that there is different guides out there, different materials and different qualities. This guide here, believe it or believe it not, is actually a Volkswagen guide. Sorry, this one is a Volkswagen guide and this is a BMC guide. I use this guide for the exhausts and I use this guide for the inlets. It's a much nicer guide. It has a better bullet nose taper straight from the factory, and I've just had really good success with it with stainless steel valves. So I use that one on my inlets. So we stand on the inlet ones there. And our 2 inlets there. And then the lower taper on the exhaust. Why do I use a lower taper on the exhaust? They have a better ability to remove heat. So when we use the higher taper on the exhaust, what happens is it doesn't take away as much heat. And you have a lot of heat in that area, and you want the exhaust valves to last as long as they possibly can. So it makes sense to use the bullet nose taper. We get better flow on the inlets, there isn't as much heat in there, and then use the other guide on the exhaust. What I have here is a spacer I made up years ago, and I have 3 or 4 of these for the different heights. For a Cooper S cylinder head with iron guides, the recommended factory fitted height is 5,900 or 14.95 millimeters. So that spacer's at 5,900 or 590, should I say. And it basically means then that I can put this guide in. I have an installation manual which just literally sits inside the valve guide, and I push the 2 of those together until they go flat. Now, I have had great success in the past starting off this process with the mill and then moving on to using literally just, I drive them in with the hammer afterwards. So I just use the quill of the mill to start them, to get them going straight. And then once I have them going straight and going in parallel to the cylinder head, I just tap them in with the hammer after that, and that works absolutely perfect, and it gets me a good result. So I'm just going to put a small arbor into the quill. So I'm set up now. I have my mandrel in an ER32 collet, and I'm going to use this to push in. Just before I show you how I do all this, I just want to say 2 things. One, Billy said to say, sorry about the focus at the start. Something weird went wrong with the autofocus on the camera, and it was doing its psychedelic impressions of zooms in, zooms out. He has it switched over to manual focus now, and it's working fine. We're a little bit out of practice, the 2 of us here. We're wobbling around this workshop trying to make a video like a pair of feckin' Ludermans, but we're getting there. And secondly, can I just say thank you very much to everybody who's following the videos. Thank you for watching them, and I know the regularity isn't as much as it normally is. Hopefully within the next while we will get back to doing weekly videos. It's just, as it is, we're doing our best. It's, you know, busy time of year, summer, and all those kinds of things that are going on. The shop's flat out, we're flat out. But we'll make videos as much as we can and as regular as we can. Thank you to anybody who is new to the channel. You're most welcome. We've a little community here. Come join us. Hit that subscribe button down below and get to be part of it. If you are a regular, thank you so much for tuning in. It's great to see all your regular names in the comments and all the good feedback that we get on all the videos. And yeah, enjoy the rest of the video. So next thing we're going to do is we're going to push in these collets. Now, for those that are about to start cringing and say, Jesus, he's not putting in valve guides with the quill of his milling machine, I'm not. And you should never. The quill and the downfeed gear for the quill is not it is by no manner of means a fly press. And you shouldn't use the quill of your milling machine as a fly press. What I use it to do here is just to start my valve guides. Literally just that. I give them a little squeeze, no harder than I'd press a drill bit. And what it's doing is it's starting off my valve guides parallel. That's literally all it's doing, nothing else. So this is not a case of using the milling machine as a fly press. We're literally just using it to start the valve guides off in a true fashion, so that they're standing up straight and they're going in straight. That's literally all it is. The cylinder head is trammed in parallel with the axis of the milling machine. So literally the only thing we have to do is line up the guide with the mandrel. And when we're lined up with the mandrel, then we line that up with the hole in the cylinder head, and then that stops us from being out of through this way, and we're already in through this way, so we've nothing to worry about. Give it a little shove in like that and press each one in. What I'll do then, once I have that done, is I will take the mandrel out of the collet in the spindle here, and I will then just tap these guides home with the mandrel, a soft or a copper hammer. That's literally it. That's all I do. Just a little squeeze like that, and it just literally straightens up the guide and puts it in. People say, how much do you use your Bridgeport pole? There's a very strong reason why I've always wanted one. Because for me, there's a tool like this in the shop, there's very little it can't help me with or can't do. But a tool is only as useful as the, the way the machinist uses it. So now, that has all the valve guides in and standing up dead straight. And literally all we have to do now is put the brake on the machine, pop out our mandrel, which we have made. We have our spacer here. Which sets the depth. So that sits down over the valve guide like that, sets the depth. Mandrel goes in there and that gives us our drive, and then we literally can just tap in our valve guide. Hear that nice solid tap, and we know we're down and we're at height. Somebody recently said on a video, actually one of the big mini engineering companies, something about not tapping in valve guides because it'll destroy the top of the valve guide or something like that. Look, at the end of the day, if you're hitting them that hard without using a properly designed and machined mandrel, I've shown you this before, my mandrel is designed in such a way that there's a small taper on the inside there, so that I only hit the valve guide on the outside. I don't hit it in there in the inside, in the center of the valve guide. I'm hitting it on the outside. That's not where the valve is going to run. And anyway, it's completely beside the point, because once I install these valve guides, I'm going to ream them. So if there's any damage whatsoever to the top of those valve guides, they're going to get fixed by reaming it. Yeah, you could put these in the press. You really could. But it's overkill. It's just not needed. And having put as many cylinder heads together as I have at this stage, and I've never ever had a problem with a valve guide, ever. Because when you put them together properly, you don't get that. You don't get that problem. Okay, another piece that I haven't overlooked, but I haven't talked about, is the dimension in here. So there's a dimension in there which is a press fit that's holding that, or an interference fit, or a semi-interference fit that's holding this valve guide into the cylinder head. I have measured all of those with a snap gauge. So I have snap gauges, or go no go gauges. In this case, it's a snap gauge. I keep meaning to get onto the brilliant measuring tool company that I work with and get a no go gauge made, but I haven't got around to it. So I put a snap gauge down and I measure that bore, and I check each individual one to make sure that the hole in the cylinder head hasn't gotten wallered out and isn't holding the valve guide properly. Now, I have oversized valve guides. I have a small selection of oversized valve guides in stock. So if I find one of those holes in the cylinder head is out of spec, I can bore it a couple of thousandths and put a slightly bigger guide in there, which will take up that clearance or that out around. This cylinder head was bang on. In fact, I actually bored one of the valve guides because it was too tight from factory. So for a cylinder head as old as these are, that's pretty good going to have a valve guides that are still absolutely on the money. But they're exactly right. And to be honest, tapping these in, I can actually feel, just, you know, it comes with experience, I suppose, but I can actually feel if the valve guides are the right tightness. If they're too tight, you have to hit them too hard. If they're too loose, you're not hitting them hard enough, and you'll know almost straight away whether valve guide's right. But we do check it. It is something that we check every single time. Now, what that means now is we have all our valve guides installed and they're all now at the right size. We have all our valve spring seats machined down. Now, these valve spring machine seats are too low. You couldn't put a valve spring straight into these now with a top cap and a valve. They're actually too low. So we are going to have to put shims in these when we're putting this cylinder head together in a week or two's time, when it comes back from getting its valve seats machined for its new valves. But I'll show you that in the last part of these videos when we go along. Okay, next thing we have to do is get set up to lower the combustion chambers, and I'm going to show you why that is in a minute. So when you come back, I'll have the cylinder head flipped over and it'll be ready to do the next part. Okay, I've flipped the cylinder head over now, and the next thing I have is I've got a special cutter I made up here myself, and what this is it's a Cooper S valve seat, or sorry, valve head diameter plus 50 thousandths. So that's 50 thousandths bigger in diameter than the valve that is going to go in here. I have worked out a measurement here which is going to get rid of the original valve seat. So I've measured the original valve seat, I've measured the height from the combustion chamber, and I'm going to come down to a measurement on my dial gauge which is going to be 0 here, 6 on the inner circle. And what that's going to give me is the height of the new combustion chamber. What that will do then is it'll mean when we grind out the combustion chamber to that height all around, we'll have fresh cast iron to cut the new valve seat into. It's just literally a case of bringing this cutter down, and I'm watching on my dial indicator gauge. I'm bringing it down here till it starts cutting, which it's doing now. It's currently at 5. So we're going to bring it around here, which is about 1 millimeter or so is what we're taking out. So it's cutting away here. Only a small bit to go now. Coming up to our 0. I run this cutter very slow because it's a shearing cutter and I don't want it to catch. I have the milling machine wound right down so I can actually stop this cutter if I wanted to by just pressing this down. I don't want at this stage in the game to damage a valve seat, tear it up or to cut it or anything like that. I'd rather just take my time and cut this in really slow. So I'm going to get Billy to come in a close-up here now. I'm going to shine the light and show you what we've got. So what we now have is we've taken out the valve seat. It's pretty much all gone. There's a little bit of the back cut there, but pretty much all of the valve seat is gone. Wait till I get the air there and give that little blast. So you can see we've cut right over here over the exhaust, and we've got this lovely flat portion here. That is what I'm going to reference. The next thing I'm going to do is I'm going to put in my 2-flute carbide end mill. This guy, going to replace that. I'm going to bring it down until it lines up here with the surface of the cylinder head, that flat surface we've just made, and then I'm going to hog out the combustion chamber. Okay, so that's those hogged out. So basically what we've done now is we machined with my special cutter down to give us a chamber height that I was happy with, and then we've come in with the 2-flute carbide end mill, and we've just run around the chambers here. So what you can see is that I haven't gone in anywhere near the edge of the chamber. All of this is going to have to be blended with grinding stones. All I've done is literally just flattened out the combustion chamber in all the major areas that should be flat in the combustion chamber. What this has now left us with is this lovely big space here between the inlet and the exhaust, and it's got rid of that old seat that used to be there. So what now can happen is we can go over next to the grinding bench, and I can start grinding these combustion chambers into the right shape. Then the valves can go into the valve guides. The cylinder head will go off for these valve seats to be 3D machined on our sister company's Newen 3D valve seat cutter. We're over in the grinding bench now. This is where I grind all my cylinder heads. It's in a little tucked away corner of the workshop. It's a really messy, dirty, dusty process, and I like to just keep it over here out of the way of everything else. What needs to be done now is we have a Cooper S inlet valve and a Cooper S exhaust valve, which needs to go into this cylinder head. But before the seats are machined for these, what needs to happen is the combustion chamber needs to be brought back into shape. Now the way the combustion chambers are brought into shape is using grinding stones. So what we use is something like this. This is what we call an electric die grinder. And we use grinding stones, the likes of this type of stone and this type of stone. The major stone goes in and it brings out the flat corners of the combustion chambers. I have a very nice radius machined onto this stone, which puts a lovely radius into the combustion chambers and keeps those corners right. And then we go in afterwards with this guy, who you'll see is sort of, this fella is kind of keystone shaped. And that guy goes in and allows me then just to really take those combustion chambers out, make them really nice and smooth. Then we get in with a combination of the pencil die grinder, which is this fella, and it takes little small flat sanding discs, and we get in there and we flatten out that combustion chamber to blend the edge of the combustion chamber to the edge of the combustion chamber. So we get a lovely radius in there and a lovely blend. One of the things that you have to also have when you're doing this is something to protect the valve seat. So we've created this lovely flat base here for a valve seat to be cut into. And the last thing we want is to slip at one of our grinding stones and actually damage that. So what we do is we have some specifically made up valves. These are really ground and machined weird, but they sit exactly dead flush on the combustion chamber. They're just barely proud there. What that allows me to do then is to grind away there in complete safety, knowing that I'm not going to hit my combustion or my valve seat area, only going to hit the combustion chambers, and I can work off of that to continue to make sure that I keep these lovely flat combustion chambers that I've managed to get in here. Rather than showing you this grinding process, to be honest with you, I end up wearing loads of PPE. The place fills with dust and it's a mucky operation, not nice for a filament. What I'm going to do is I'm going to show you one that I have done. So if you follow me over this way, Billy, my apologies, I know you're on the old manual focus. I've been thrown a really at poor Billy today. He's been on the manual focus. But this is what a finished combustion chamber would look like now. So what you can hopefully see here now and is that we've a lovely flat combustion chamber floor. We've a lovely blended radius in here between the bottom of the combustion chamber and the side walls of the combustion chamber, and we've got that loads of lovely space. Now I have started just clipping these seats just to give myself an idea where the valves are going to go. There's the inlet, there's the exhaust for that cylinder head. That gives me an idea where they want to go. What's going to happen now is both of these two cylinder heads are going to go off out to another local machine shop, a very good friend of mine, Martin, and he's going to do the valve seats with these using his phenomenal Nuon CNC valve seat cutting machine. I could cut valve seats here. I have the New Way equipment, the New Way valve seat cutting equipment here. I bought it a few years ago. And to be honest with you, it would do a valve seat job on these heads that would be, in fairness, more than good enough for what they are. However, people here are getting to know that perfection is always my ultimate game. And when I found Martin's had this Nuon machine, the valve seats that come out of that machine are just absolutely phenomenal. Every time we test the valve seats after them, we get near as damn 100% sealing. No grinding required, no lapping, no nothing like that. It just cuts these seats absolutely perfect. The more perfect you can get a seat in one foul swoop, the better it's going to be, the longer it's going to last, and the better it is. We'll give these maybe the slightest rub with 1500 grit valve grinding paste when it comes, for nothing more than just to satisfy myself. But to be honest with you, if I tested them with the vacuum valve seat tester, we'd get 100% vacuum on them. They would be perfect. So to conclude this video, that is the stages of machining of these cylinder heads. So we have gone from doing our top surfaces to get our cylinder heads the right thickness. Then we did our valve spring seats. We put our new guides in, we reamed them, we centered up on our valves and cut down our combustion chamber floors. Then we used the 2-flute end mill in the Bridgeport to hog out the flat combustion chamber. We went over to the grinding bench. We ground in the combustion chambers to get this really nice, good flowing combustion chamber. And now the cylinder heads are going to go off, get their valve seats machined. Another lovely thing that will happen with the CNC Noon valve seat machine is it's going to leave every one of these valves at the exact same height, because it has a lovely reference to go off of now. The combustion chamber reference we made is a really good reference. It'll cut all our valve springs, our valve seats to the right height. We can then put all our valves into the cylinder head, put top caps on them, measure them, set our spring seat heights, and then all that's left then is to run a tap through all the different threads, wash these cylinder heads thoroughly, treat the insides for anti-corrosion, put our valve springs in, put our top caps on, and box them up and send them back to America for Cole to get working on his Cooper S engine build. I hope you guys enjoyed. In the next video, hopefully we're going to finish off those Cooper S rockers, and then hopefully the last video in this sort of series will be these cylinder heads coming back and us getting a chance to reassemble them and show you that process. After that, I can't wait to show you some of the other stuff we have to video. There's loads of really exciting stuff happening here at H3. Cars are getting finished, new cars are getting started. So stick with us. As I said, sorry for the little bit of a slowdown in videos, but there's great content coming and I'm glad and look forward to sharing it with you guys. See you guys on the next one.